So let's talk about carbohydrates. Okay, there are many examples of carbohydrates, including potatoes and a lot of cereals and products of cereals, such as the bread, spaghettis, and also different types of fruits. Okay, they are examples of carbohydrates. And for the word carbohydrates, carbo means carbon. Okay, and hydrates means water. Okay, but it doesn't mean that there is water inside the carbohydrates. It is just because the chemical formula of carbohydrate is CH2OY, and the ratio of H2O is equal to 2 to 1, which is the same as water, so we call it carbohydrates. And actually the name for that carbohydrate is a bit misleading. Okay, actually no water inside the carbohydrates just because of this ratio. Okay, for all kinds of carbohydrates we have C, H, and O, and carbohydrates are organic substances. And you know what is the meaning for organic substances? Organic substances means we have long chain of carbon atoms. Okay, and according to their size, according to their molecular capacities, or molecular size, we classify carbohydrates into three groups: the monosaccharides, the disaccharides, and the polysaccharides. Mono mean single, okay, and di mean double. Poly means multiple. So according to their size, we can have three different types of carbohydrates. And you have to remember this formula, and you have to write it down in your textbook. Monosaccharides is C6H12O6. You have to remember this one, okay? And we go to monosaccharide first, and we have a lot of examples which you already learned it in Form 3. We have glucose, okay, and we have fructose in fruits, okay. Glucose and fructose are monosaccharides, very simple sugar, okay, very simple monosaccharides. We have one more example. Do you still remember that? We have in milk we have galactose. Okay, galactose is also sweet, and it's present in milk. And we have three common examples of monosaccharides. We also know that OSE means sugar. Okay, so all these examples ended with OSE. They are very small molecules. They soluble in water and usually sweet in taste. Okay, because they are small enough to cross the wall of small intestine, we do not need to digest them before absorption. We can directly absorb monosaccharides without chemical digestion. And how are monosaccharides metabolized in the body? Metabolized means broken down. Okay, how can we break down monosaccharides in our body? Okay, we break down glucose, we break down fructose or galactose by respiration. Okay, respiration is a kind of chemical reaction, and it is catabolism. Still remember that breaking down process. Okay, during this process, energy is released. Okay, but now we use a more difficult word, say metabolize. We do not use break down, okay? We use metabolize. And this is the immediate energy field, energy source for our body activities. That means if we need energy, we will take in glucose, we take in galactose or fructose. We can have energy very soon, okay? Because the chemical reaction of respiration is very simple. We can directly use them as biofuel for our body. And the word equation for respiration, if you still remember, is glucose plus oxygen become carbon dioxide plus water, and energy is released. Energy is in form of ATP. If you do not know what is ATP, it doesn't matter. You have to know that ATP is bioenergy. Okay, these are things that you have to understand for monosaccharides. And the last thing is that very biochemistry. monosaccharides, the structural formula of monosaccharide is something like that. Okay, we know that all of them are C6H2O, CXH2OY, and we have 6 carbon. 1, 2, carbon number 1 here, number 2, number 3, number 4, and number 5, number 6. Okay, 6 carbon for glucose and 6 carbon for fructose, 6 carbon for galactose. All of them are C6H12O6. Okay, but the arrangement is different, so they are different monosaccharides. And the molecular shape is very much like a hexagon. So sometimes we draw this symbol to represent monosaccharides, and some of the monosaccharides are like pentagon. Okay, so we draw this diagram to represent fructose.